So next up is the binary search. So the binary search algorithm is a little bit slicker than the linear search algorithm in the way that it tries to find if a particular key value is in an array. However, it only works if the array is actually sorted. Okay, if the array is not sorted, then your binary search is not going to work. The way that the binary search works is it looks at the beginning and the end of the array and marks them off, and then it figures out what the midpoint is. Okay, so here we have 11 elements in the array. The midpoint is position 5, so I'll move my little marker there. So the first thing it does is once it establishes that midpoint is it compares our key value to the midpoint. Okay, so obviously 11 is not 21, and then it looks at whether or not the key value we're looking for is higher or lower than the value stored at the midpoint. Okay, so since it's higher, what it does is it actually shifts the beginning and the end of where it's going to be searching. So it's only going to be searching now higher than position 5. So then it determines what the midpoint is again. Okay, so between 6 and 10, the midpoint is 8. Okay, so it compares position number 8, okay, with the key value. 19 is not 21. So again, it makes that same decision. Is 19 smaller or larger than 21? So it figures out that it only needs to search this portion of the array. Okay, so we're down to the last two. Okay, it figures out the midpoint. Now, obviously, there's an even number of elements, so it'll default to the lower element, and it finds that position 9 is the quote-unquote midpoint. It's the start point as well in this example. Okay, so 21 is 21, so it found it. Okay, so now we know that the value we were searching for is in position 9. That's the binary search. So this is how I've implemented binary search in my array templates header file. Okay, so the array is called source list. The size is size, and of course there's the key we're looking for. So I've defined those boundaries of the array as left and right. So at the beginning, left is position 0 and right is the far right position, which is size -1. Then we'll calculate what the midpoint is. Again, just like the linear search, I'm using a variable called found@index, which is defaulting to -1 in case I don't actually find what I'm looking for. So I go into a loop. Okay, so while I haven't found the key value, and as long as my left index is less than or equal to my right index, I'm going to continue looping. Okay, so if my left index is larger than my right index, that means I haven't found it. Okay, so I figure out what the midpoint is. So I take my left index plus my right index and I divide it by 2. Because of integer arithmetic here, again, if it's an even number, it's going to default to the lower index. So I look at the array at that particular midpoint and I compare it against the key. If it's the same, then I've found what I'm looking for. Okay, so my found@index is equal to midpoint. And that, of course, will shut that loop down. Otherwise, I look to see if the key is larger than the value that I'm on. If it is, then I set the left boundary as the midpoint +1. So I basically eliminated the whole bottom part of the array for searching. Otherwise, it's the opposite, so I shift the right boundary of where I'm searching to midpoint -1, eliminating the top half that I don't have to search through anymore. So that continues to loop until it either finds it or it runs out of indexes and it returns found@index. So we'll see that in action. Now first off, I'm leaving in my selection sort test because again, binary search doesn't work unless it's actually sorted. So I'll leave that code in there. But otherwise, it's just like how I set up the linear search test. I have a key. I call my search function and I record the index that it returns back. And if that index is greater than or equal to 0, that means I've found it, and I show what index I find it in. Otherwise, I didn't find it. So I say that I didn't find it. So we'll run this. And we can see it found F in position 2. Okay, so 0, 1, 2. So it was successful. Like before, I'll change it to something that isn't there. Oops. Well, 1 isn't there, but Z. And we'll run it again. And you can see that it picked up that it didn't find anything at position Z. Okay, so that wraps up sample program 8. It was a bit of a long one, implementing various different basic sorting and searching algorithms. You can download this code from DC Connect and pour over it if you want, because it's a lot to take in. But that's the last sample program for this unit. Thanks very much.